Hello, so I'm going to show you how to do reacting mass calculation in chemistry. I've got a couple of questions to show you. I'll probably spend a bit more time explaining the first one and then I'll go a bit quicker in the second one just to show you what you need to do. So, first things first, I would write the equation out. And then start adding on the values that they've given you. So the only value they've given you is the 6 grams of magnesium here. Okay, now it does ask for what mass of magnesium oxide is formed, of course, but the mass they gave you was for the magnesium. So you should be writing that here below the magnesium. And I make this into a mass column, because that's what it is, okay? Of the two that I need to write are the MR and the moles, because the equation that links all this together is that the moles is equal to the mass in grams divided by the MR. Okay? So the MRs, just so you know, these just come from the periodic table. So if we focus on the magnesium, for example, Mg would have the number 24 above it. So that's its MR, that number there. Great. So you always want to work with the thing that you was given the mass for to start with. So that's the magnesium. And then we can calculate the moles, because remember the moles is the mass divided by the MR, and if you look here we have both of those, so we can do 6 divided by 24 and that would give us 0.25. Okay, I'll just write 0.25. So that's magnesium all sorted out. But they ask for magnesium oxide. So there's a little trick that you can do with the balanced equation. And that is using these numbers that you see at the front. There is actually one here as well. So it's just like maths, when you see an X, there's actually a number 1 in front of it. So there's actually a 1 there. And that's given us what I call the mole to mole ratio. So it goes 2 to 1 to 2. So that ratio allows you to work out the rest of the moles, which is really useful in chemistry. So since we have a 2 for both of these columns, this moles will be the same. And the one in the middle should be half of what the one was for this. Just like ratios in maths. From 2 to 1 we divide by 2. So that would be 0.125. To get the MRs, remember, of the other two, we can just get those from the periodic table. This question only asked for magnesium oxide. So I could really just work with this column and that would be it. So to get the MR of magnesium oxide, I would need both magnesium and the oxygen. So they're the entries from the periodic table. Add in the 24 and the 16, since we have both in here, gives us 40, which I'll put in the MR column. And the last thing to do is to calculate the mass, which it asks for. So if you go back to your equation up here, you see that mass is at the top of the equation. So to rearrange for mass, since it's being divided at the moment, you would like to multiply these two here, the moles and the MR. So you can see that that's these two. 40 times 0.25, that will give us 10. Okay, so there you go, 10 grams, that will be your answer for that question. Now, something I want to show you here. Since the equation is 2 magnesium plus oxygen gives you 2 magnesium oxide, basically what's going on is you should find that the mass is consistent on left and right. So the mass of the reactant should equal the mass of the products. So I want to check that now. So here's the mass of the product, 10 grams. So this should technically be 4. So let's check that. MR of oxygen, this one is O2. So if it's O2, it means you've got 2 oxygens bound. And so because the number's 16, for this MR, you need to do 16 times 2, which would be 32. And if you was to times these together, you should find it gives you 4 grams. And therefore, if you add 6 and 4, it equals 10. Okay, let's move on. Apologies, because that should be clear. Let's just do this. So, I'm going to write it out. There we go. So we look at the mass we were given again, remember, at the start. So it said 4.6 grams of sodium this time. That would be this one. So just writing my MR and my moles as well. Straight away go for the MR of sodium. Now you should see again there's a 23 above the sodium. Don't get confused with that 2, that's for the mole to mole ratio. So it's just 23 for this. To work out moles, you do mass divided by MR. So that's 4.6 divided by 23, which should be 0.2. That's sodium done. Next one, well, I say next one, the only thing we've got to do is to get sodium chloride in this question. So that would be this one. So let's use the mole to mole ratio. We've got 2 here and we've got 2 there. So that means the moles will be exactly the same. Okay. Now we need the MR of sodium chloride. Sodium in the periodic table has the 23, remember, and chlorine has 35.5. If you used to add 23 to 35.5, that would give you 58.5. And finally, if you used to multiply these two together, that should give you 11.7. which would be the answer to this question. Okay. Okay. This is the product. So let's find out what this one is here and add it to this to check if it equals the answer, because it should do. So there's actually a hidden 1 in front of that chlorine. So I have to divide by 2 to get the moles of this one. So that'll be 0.1. Cl2, remember it's got the 2 there, has 2 chlorines. So that's 2 35.5s, which gives me 71. And if I multiply these, just like dividing 71 by 10, which gives me 7.1 grams. And if I was to finally add those, you should find it gives me 11.7. Okay, I hope that video helped. If it did, please do like and subscribe, and ask me any question you want, or feel free to drop me a comment and suggest something really for me to go through. I'll be doing other things in chemistry like balancing equations, and I'll be providing some more maths GCSE content and lots more to come. Thank you.